So to determine the future value of that kind of deposit, so I'm not sticking one amount of money in and then just it sits. I'm starting with some amount and then I'm depositing $20 every week or whatever. This is our formula. P is, or well, let's start with B. B is the balance at the end of whatever term you've decided. So if you want to know for 3 years or 5 years or 1 year, this is the end of that term. P is no longer the principal, it's the periodic investment amount or deposit. So here it would be $20. Here it would be $150. R is the annual interest rate still. N is the number of times compounded still. And T is years. So really the only thing that changed was the P. And if you look, what we had before was a capital P. This is actually a lowercase. No, there was a lowercase p too. Never mind, just P. So principal in the normal formula, periodic deposit in this formula. Should change it. All right, so what we have is Rich and Laura are 45. They open an account at Rhinebeck Savings Bank with the hope that it will gain enough interest by their retirement age of 65. They are going to deposit $5,000 a year into an account that pays 4.5% interest compounded annually, and we want to know what is the balance going to be when they retire. Okay, so we're looking for B. P is $5,000 a year. N is 1. T is 20, because 45 to 65, 20 years. Any questions on that so far? And R is 0.045. So I'm going to take my formula. And I'm going to plug in all these numbers. So I have 5,000. 1 plus 0.045 divided by 1 to the 1 times 20 minus 1 over 0.045 divided by 1. Now, order of operations is very important here. This division first, then add 1, then raise it to a power, then subtract 1, then multiply by 5,000. Okay, so we work inside to out. So 5,000 times 1.045 to the 20th minus 1 over 0.045. So I need to find out what is that 0.045 to the 20th. Oops, 1.045. So 2.41, et cetera, et cetera, et cetera. I'm going to subtract 1. I'm going to multiply it by 5,000. Then I'm going to divide it by 0.045. And I'm going to get $156,857.11. Okay. Figure out how much interest they would earn. Well, how much are they depositing? So we take that $5,000 a year and we multiply it by 20 years. They're depositing $100,000, right? And then we take what they actually earn That's a comma, not a decimal. And we take 100,000 away from it. So they are earning $56,000 in interest. All right, Lynn and Rob are going to open a savings account that has 3.6% annual interest compounded monthly. They're going to deposit $1,200 a month. How much will be in the account after 10 years? Now, did you notice that this was annual compounding, $5,000 a year? And this is monthly compounding, $1,200 a month? The compounding and the deposit amounts need to match. So let's say, I didn't say $1,200 a month here, I said $1,200 a year. I would have to divide by 12 to find out how much I'm doing per month. So you take your deposits and make them match your compounding period. So if I was going to do $100 a month, but I was going to compound daily, I would divide it by, I would take the $100 a month, which would be $1,200 a year, and divide that by 365 days to find out how much the deposit was per day. Does that make sense? Your deposit period and your compounding period have to be the same amount of time. So you adjust the money that you're depositing to match the compounding. Better? Okay. But so here it already matches, so we're okay. So my P is 1,200. R is 0.036. N is 12 because it's monthly. And we want to know 10 years, so that's going to be 12 times 10 minus 1 over 0.036 divided by 12. All right, so 0.036 divided by 12 is going to be 0.003. 12 times 10 is 120, and then this 0.003, same. So I have that 0.003, I add 1 to it, raise it to the power of 120, subtract 1 from it. Let me see if I did that right, sorry. Yes, okay. Subtract 1 from it, and then multiply it by 1,200, and then divide by 0.003. So 173,022.87. So if you deposit $1,200 a month at 3.6% annual interest compounded monthly in 10 years, you'll have $173,000. Okay, so we have future value of a periodic investment. So I say I'm going to put away $20 a month. How much will I have in 10 years? So that's future value. Then we have present value. That's where I say I need $40,000 in 10 years to pay for a house down payment or a college for my son, or whatever your goal is. I want $7,000 in 2 years to buy a car, however that is. This allows you to work backwards. So you say, okay, I need this much money at this amount of time. How much money do I have to put away every month or every year or every week? So this allows you to have the goal amount and figure out how much you have to put away. So the ones we just did was you know how much you're going to put away and it gives you a final amount. This one is you have the final amount in mind, and this allows you to figure out how much money you have to actually put aside every week or month or year, whatever your period is. So the B in this is the future goal. So your future balance. The R and the N and the T's, and this is either the principal or the periodic, depending on what you're trying to figure out. Single deposit formula. Okay, with a single deposit, we want $20,000 in 6 years to pay for the first year of college. So how much do they need to deposit in an account that has 5% interest compounded annually? So we're going to use this formula. Okay, so we have the balance we want is $20,000. A 1 is just a 1. Our rate is 0.05. It's compounding annually, so we're dividing by 1. And we have 6 years. So we're going to do 20,000 divided by 1.05 to the 6th. Okay, and when I do that math, I get, yes, see, if I want $20,000 in 6 years, I need to put away close to $15,000 today. But she just graduated from college and she wants $100,000 in her savings account in 10 years, probably to buy a house. And she has a 3.8% interest account, and she wants to know how much does she need to put in there compounded daily to meet her goal. So again, this is a single deposit. Where N is going to be 365 because it's compounded daily. We're going to ignore the leap years. And R is 0.038 and T is 10. So she wants $100,000. To 365 times 10. So we get 100,000 divided by 1.000104 to the 3650, and I did round on this one because there's really no way to keep this in the calculator with one of these kind of basic calculators. So that gives me 100,000 divided by 1.4622556, which gives me $68,388 that she'll need to have in the account today to have $100,000 in 10 years. He wants to do this in 3 years, and he thinks the total cost will be about $15,000, and so he wants to deposit monthly into an account that compounds monthly. Again, my deposit amount and my deposit period and my compounding need to match. So we need the periodic investment formula. Sorry, that's sloppy. Let me fix it. Okay, so it's B times R over N over 1 plus R over N to the NT minus 1. So I want to find out how much he needs to put away to have $15,000 at 4% interest, compounding monthly. And we're talking about 3 years, so it's going to be 12 times 3 for this exponent, minus 1. So I have $15,000 times 0.00333 repeating. So just round it. So then I have 1.0033 to the 36 minus 1. Okay, 15,000 times the 0.03s that repeat end up giving you 50. And when I take 1.03s repeating to the power of the 36 and I subtract 1 from it, I get 0.1272787 and then a bunch of other numbers. So when I divide 50 by some rounding of this, I usually keep about 6 digits. He's going to have to put away $392.86 monthly. So he'd probably put away, it says round to the nearest hundred, $400 a month.